and one for the intelligent as fellas get. Listen, let's settle this. Be clear, I can fall back 7 years, still it ain't no one ahead of me. Consider it a blessing if you get to stand next to me. 5-star general, OG veteran, cake like.
What's up, everybody? Welcome to Bios3 Raw TV. So today we're going to do something very different outside of my comfort zone. You guys can see the white dry erase marker board behind me. I am not a professor. I'm not a teacher. I am not the classroom type. I'm not somebody who, can teach, I guess, per se, whatever. But I got a lot of questions on highly branched cyclic dextrins, why I use them in the intracell product, how to use them. They want to know more about them, and I described it what I thought would be very in-depth and understandable, but it seems like sometimes you need a little something different to learn. And I actually mapped it out on a piece of paper for an individual that asked me, and when I drew it out, they understood it a lot better, and I was like, shit, I have to do this, but drawing it on a piece of paper is kind of fucked up. So here we are, the white marker erase board, and we're going to try to do this thing as best we can and see if this works. So we're going to talk about highly branched cyclic dextrin, HBCD. I don't know if you guys can even see that up there. We're going to have to darken that up a little bit. CD. Highly branched cyclic dextrin. Okay? Now, what these are, it's a carbohydrate source. They're mixed in water. I guess if you mix them in milk, it digests a little bit slower. Mixed in water, it digests very quickly. It gets through your body, into your bloodstream very quickly within a matter of minutes. Now, why is that important? You want these carbohydrates specifically to be in your blood, not for a carbohydrate source. You want an effect, but not to technically be used as a carbohydrate. Now that's where there's some confusion. So we're going to kind of diagram this out. So the highly branched cyclic dextrins are actually cone-shaped in their structure. Okay? So these cone shapes, as you can see, now they start going through the bloodstream somehow. I'm not really sure how, but the scientists explain it. They start going through the bloodstream in this direction with the big part first. Now, what you have over here is the muscle cell, okay? The muscle cell. Now, inside the muscle cell, amino acids, glycogen, vitamins and minerals, creatine, anything that you can shove in there to make the muscle anabolic is all going to go into the muscle cell, including water, keeping it super hydrated. Without enough water, again, you're not anabolic. You need all these things together to make the muscle cell as anabolic as possible. Now, as these highly branched cyclic dextrins go through the bloodstream, you have creatine, amino acids, carbohydrates, vitamins and minerals, all getting shoved directly into the muscle cell by these things pushing them into the muscle cell very quickly, along with more water. Now, once these things are inside the muscle cell is now anabolic. So you have, let's back up again. So now you have to start with first the muscle stimulus to get the muscle to actually grow. The muscle then has to recover to be able to grow, and then finally growth. Okay, that's the process. If that doesn't take place, growth will not fucking take place. You have to have the muscle stimulus in the gym, recovery afterwards, and growth. This process right here increases recovery. You recover faster. So if you're taking a scoop of highly branched cyclic dextrins with your creatine and everything, amino acids and everything before your workout, okay, you actually have a fully hydrated, fully anabolic cell before your workout. Your body will recover better during the workout. Now, if you have a long workout and you're actually taking the highly branched cyclic dextrin, something like intracell during the workout, you're actually recovering in between sets. You have all these things in the bloodstream already being shoved into the muscle cell while you're training, or as soon as you're done training, that stuff's being shoved into the muscles actually recovering. Now when you get out of the gym, you take in your, let's see, post-training nutrition, whether it's a meal, it's a shake, or whatever the case may be, and now you have a fully hydrated, fully anabolic muscle cell that is ready to recover at a faster rate. Faster recovery equals faster growth. Faster recovery, faster growth. The more times you can train, the more results you're going to get, the faster you're going to get it. Now, there are other things inside the intracell, like glycerol, which superhydrates the cell, which gives even more water inside the cell. Branched chain amino acids, along with the nitrogen, which is actually increases red blood cell count for a long period of time. All these things are basically to get this muscle cell to have everything in there as packed as it possibly can to have the fastest recovery possible. And now, we actually have to open this eraser over here so we can get some of this shit off here. We have to talk about how this works with the effects in general. Now, you have the highly branched cyclic dextrins, which essentially are the cone-shaped molecules, correct? Now, what we want these things to do, these cone shapes, is to actually work like insulin, but not be insulin, if that makes any sense. Raising your insulin levels can actually be bad, and they've said mortality rates in general, you're going to live a shorter lifespan if your insulin levels are high. You don't want to spike your insulin like they used to do back in the day and have a blood sugar drop. You don't want to do these things. So if you can use something that would work like insulin, which these molecules shuttle all the amino acids, all this stuff into the muscle cell over here, like insulin, but not hormonal. It's not insulin, it doesn't use insulin. So now what's happening is you're not using, let's say you take 5 grams of highly branched cyclic dextrins, or 10 grams, or 20 grams, okay? Obviously, the more of this you take, the more of these there are going to be. The more of these there are going to be, the more of these amino acids, carbohydrates, vitamins, minerals, etc., get into the muscle cells. So you can actually get a small effect from taking 5 grams of highly branched cyclic dextrin, a bigger effect from taking 10 grams, an even bigger effect from taking 20 grams, but it's not necessarily the carbohydrates that we're looking to use as an energy source. We want them to get the effect. We want these little guys right here in the bloodstream, not for energy. We want these guys in the bloodstream to move all these things into the muscle cell itself to get the body to recover faster. So be aware, highly branched cyclic dextrins can be used as a carbohydrate source. That's not what I use them for. That's not what I suggest people use them for. It can actually get pretty pricey. But they're actually used as a tool to use instead of insulin to get an insulin-like effect. It's hard to say that, but you're getting an insulin-like effect without actually producing the amounts of insulin that it would take to get that result to happen. And in the end, what you're going to have is a fully hydrated, fully anabolic muscle cell that recovers faster, which in essence gives you faster muscle growth. Bioswitchtraining@gmail.com. Leave comments down below, but don't fight. www.bioswitchtraining.com is a blog. Don't hate on the market board, because hopefully this is going to work out and we're out.